Hello, I'm Patty Simpson with Simpson Math. In this series of videos, we've been learning about parent functions. In this specific video, we're going to learn about the parent function of the square root functions. So let me give you some examples of square root functions. Here's an example. The square root of x plus 2 minus 3. Or in function notation, we could do f of x equals 1/2 times the square root of x minus or plus 8. Those are both square root functions. Notice that our variable x is underneath a square root sign. That's what makes it a square root function. And the simplest of those square root functions, or the parent of the square root functions, is just y equals the square root of x, or f of x equals the square root of x. Now, in all our previous videos with all our other parent functions, when we got ready to graph them and we discussed the domain, or what our x values could be, we saw that all of our x values could be any real number. But in the square root function, we have a small problem. Notice that when I put in a negative value for x, I'm going to get out a non-real or imaginary number. So for instance, if I make x equal to -4, the square root of -4, remember, is not real. That's equal to 2i. So we want only real solutions or real outputs. So we need to put in only numbers that will give us those real outputs. So when we get ready to graph this, we're going to only use positive values for our x's. In other words, our domain is going to be restricted. Our domain is restricted to, if I write it in this fancy set builder notation, our x values must be greater than or equal to 0. So we're only going to use positive values for our x. Or we could write that in set builder notation, where our x's go from 0 to infinity. So when we get ready to graph this square root function, similar to the cubed root function, we're going to want to find pretty values to help us to graph it. We could put in any positive number and get out a real solution for y, but we might not want to graph some that are not pretty. So I'm going to start with my perfect squares. So 0, I can take the square root of 0. Let's put in 0 for x. If I put in 0 for x, then that's the square root of 0, which is just equal to 0. My output then is 0. If I put in 1 for x, the square root of 1 is 1. The square root of 2 is about 1.4, but that's not a pretty number. So maybe I don't want to use 2. It's not a nice perfect square. Instead, I'm going to skip to 4, because 4 is a perfect square. And then when I put in 4 into the square root, if I put in 4 for my x value, then out comes 2. And then I'm going to do one more. The next one is 9. That's my next perfect square. And when I put in 9, out comes 3. So I'm going to graph those 4 points as my square root function. So 0, 0, 1, 1, 2, 3, 4, 2, and 9, 3. So my square root function looks something like this. Notice that my domain in this case is restricted. There's nothing on this left side of the graph. The graph starts where x equals 0 and goes on to infinity. And that's because if we put in a negative number underneath the radical, we get out a non-real number. We can't graph that here on the coordinate plane. So, and in this class, we're keeping it real. So I'm going to label my points. My 0, 0 is on both the x-axis and the y-axis, so that's my x-intercept and my y-intercept. 1, 1 is a point on that graph. 4, 2 is a point, and 9, 3 is a point on the graph. So here is my square root parent function. Thanks for watching.